Thank you guys for coming to this workshop on AI prompting. We're going to look at the ways to get the most from AI, one prompt at a time. With that being said, a little bit about myself. My name is Connor Carson. I'm currently a cybersecurity operations and strategy consultant for CyberReady Inc. Starting off, question to the room. Who here has seen the movie Hidden Figures? About the team of black women absolutely key to the Apollo missions and doing the math calculations, et cetera, with helping us kind of win the space race, right? Well, in that movie, they touch on at the very end, well, at the start of the movie, everyone is doing calculations either by hand or with small calculators, right? Again, this is astrophysics, a lot of calculations to make sure something gets into space. But they allude to the creation of the IBM 7090. This is the real picture from the computer. It doesn't even show the whole thing. This was hundreds of pounds of technology that became the next most cutting-edge piece of analytical equipment to perform these calculations at scale. And that's probably key to why we won the space race. Now, the reason I draw attention to this is, okay, you look at this being cutting-edge technology in the 60s to the iPhone right here, right? Fraction of the weight, fraction of the size. Now, pulling the room, if we had to think of the power that, computing power, right, ability to perform calculations at scale, any guess the difference between the IBM and the modern-day iPhone? Huge, correct. We're thinking 5 times, 10 times, 100 times more. It's actually millions of times stronger, the modern day iPhone to a machine like that. And the reason I'm starting here is just to really illustrate how fast technology is moving. We have, since the dawn of time, wanted to find the best tool for the job to make sure we're completing the tasks the most efficient way possible. And that's kind of how technology moves, right? We're siloing this ancient technology now in lieu of the smaller things that are more efficient and fast. With that being said, we'll move on to really a hypothetical example of a company, let's say 15 years back, right? The image on the left is a little small server rack. Hopefully we're familiar with that. Essentially, for a company, they would have their data there. And I realized I skipped over the first line of structured versus unstructured data. I guess before I get into it, polling the room, anyone have an idea of what structured data is? Or could give me an example? Rows, tables, columns, commas, right? Something like an Excel file, right? You could say, this cell plus this cell equals what? And the machine with very simple math logic can solve that, right? And most business data, for I guess, recorded history, has been in structured format to perform analysis, do predictions, the whole 9 yards. Going back 15 years to start this example, then we get the whole advent of the cloud, right? And you think, with how fast technology is moving, right, from the IBM to the modern day iPhone, something that's 15 years old, a server rack, is probably outdated or barely even functional 10 or 15 years down the line. So what does that mean? You're then presented with a choice. Do you invest thousands of dollars more potentially in a system you barely understand, have to pay someone else to use and configure for you, and you don't really see a real ROI for it, right? And that created the real business need and value for the cloud. How about we pay some really smart IT people to give us access to the data as if it was right next to us, but just simply over an internet connection? So you think of the top 3 providers, Google with their GCP, Microsoft with the Azure, and AWS for Amazon, right? So essentially it's the same premise. There is your data somewhere stored in a tower, some server rack, just in a data center far away that you can access over the internet. And that's kind of how the cloud came to be, how it is going to stay. And a lot of the models that we're talking about today when it comes to AI are accessed over the web in a similar fashion, right? Is that making sense so far? Lovely. All right. Now, the last little quick distinction to make between data science and data analytics, right? When we think of data analytics in the modern day, right? An example, I alluded to SQL, right? A language that you'd have to speak to interact with the computer and generate insights. If you didn't know that, you're kind of SOL when it comes to getting the information you need. But now, with plain English, you can ask, why was revenue down in this area last quarter? And it can generate the code for you that you could run yourself, or could even run it for you, and not just return the answer, but also return a chart and visualization you can present to management, right? What is a large language model? So I think this description is pretty apt. An AI system trained on vast amounts of text data that can understand, generate, and manipulate human language in a way that mimics natural communication. I know a few people around the room at the start referenced a few models they've used. I've listed some of the most popular ones. I did get called out for not having Copilot on there, so apologies if you're a user or a fan. But yeah, OpenAI with GPT, Anthropic with the Claude, Google Gemini, and Meta. In my previous role, we worked with, I think, over 32 industry-leading models that you could pick between whenever you wanted. So just something to think about when you're investing in AI or really putting something forward in a business context, right? There are different models that might have an advantage.